Okay, so we are doing this particular topic, okay, on applications of forces, transfer of energy. Now, this topic consists of quite a bit of things. Okay, now we are actually just more focused on pressure. Okay, so pressure, basically, you work around the same formula. You calculate pressure using this formula. You take force divided by the area, okay, that the force is being applied to. Okay, and then the SI unit, take note, either you express it in Pascal or you can write down Newton per meter square. So force, you know that force has this SI unit Newton, and area, the SI unit is square meters. Okay, and take note, 1 Pascal is actually 1 Newton per meter square. So when you need to do conversion, this is necessary. Okay, yeah. Now I can see Bernie. Good. Okay, so if we look at the first question, the diagram here shows a cylindrical object with radius 2 mm resting on the floor. Okay, so if the object exerts a force of 8 newtons on the floor, what is the pressure measured in Pascal? Okay, I have not exported the answers. Hold on, I'm just opening up. So what is the first step you need to do? Type into the chat. Okay, or you can raise your hand if you want to answer. What is the first step you need to do? Okay, when you want to calculate pressure, they gave you some information. All right, there's pi given to you. Why do you think pi is required? Find the area of contact with the floor. So which part is actually in contact with the floor? Okay, so I have quite a bit of responses now. Very good. Okay, convert something, convert mm to meter, says Chloe. Then LeBron says force over meter square. You mean force over area, right? Good. Harvard says find the area. Then the area of the, okay, bottom of the cylinder. Good. Okay, so that is the base. It is actually touching the floor. Now, okay, Sheena, if your internet is still laggy, you will have to log out and log in again. Yeah, so find the area of contact with the floor. We know that it's the circular base, right? So how do you calculate area there? This is like mathematics lesson. All right, so I have a lot of suggestion. Okay, so someone said this, someone said this. Convert this, then after that, area of contact. Okay, Hao Lun says need to take pi times 2 mm times 2. Is that right? Okay, you mean 2 mm times 2 mm. Right now. Okay, how do you calculate area of circle? I hope you all know. So area of circle, because cylindrical means it's actually a circle shape at the bottom and at the top. So area of circle, you take pi times r, yes. Okay, so the radius, okay, if let's say we were to follow this method, this one that Hao Lun suggested, okay, pi, we are taking 22/7, multiplied by 2, then multiply by 2 again. Then what do you have? Okay, LeBron, I see your comment there. All right. If LeBron actually said we cannot just directly multiply this way, okay? We cannot use the radius this way to put into the formula to calculate area. So what is the thing you need to do? I think if I didn't remember wrongly, right, Kaden, you recall last lesson you also made this error. You directly just multiply, right? You didn't convert. You recall that? when we want to find area. So what do we need to do? We have to make sure we convert to meter square. Yes. So how do we convert? You start with, you start with this step actually. You start with this step suggested by Chloe. Yeah, we convert millimeters into meter. So we are talking about 2 mm. So 2 mm convert to meters. If you cannot do conversion directly, don't panic. Okay, so convert from mm to cm first, step by step. You know, I sometimes when I was in the Sec 1, Sec 2, right, all this conversion scares me also. Yeah, so I will actually do step by step. So I know that 1 cm is actually 10 mm, right? Correct now. So this is going to be, divide by 10. So this is 0.2 cm. Then after that, I have to convert to meters. I divide by 100. Okay, so 0.002. Yeah. Okay. LeBron, you can do all that. Yes. Then you take this radius. Okay, now you put into your pi r squared. So I have to change this already. Okay, so pi r squared, maybe I can redo it. Okay, so area of contact, pi r squared. All right, so 22 over 7 times 0.002. This is bracket square. What do you have? LeBron, that one is correct. 0.0126, is that correct? Someone do the calculation. I didn't bring my calculator in. You cannot be lazy. No, I'm not doing the calculation for you. Let me see. Okay. Thank you. Now I have someone who just entered the value. Thank you, Harvard. 0. Oh my God, so many 0. This is what is reflected on your calculator, right? Yeah, it's fine. Yeah, LeBron, you missed out another -3, 10 to the power -3. You realize that? Which is why I always encourage students, like I said to Kaden the last time, if you are going to use mm to calculate area first, then you want to change square millimeters to square meter. A lot of people make mistakes there. Okay, even I myself, when I was your age, I will make mistakes. So I always use the simple method. Okay, convert everything first to SI unit. It's easier that way. Okay, so what do we have here? So we're going to take this. Yeah, it might be easier to write in fraction. Yes, correct. You can leave it in fraction because this is not the final working. Supposedly, let's say this is the open-ended question, right? Structured question. You can leave it in fraction form, right? And then the final one, then you write it in, you write out the entire answer and then convert to whatever is required. If they say 3 significant figures, you follow. Okay, now, so after that, we're going to take force divided by area. So our pressure, okay, can be calculated now. Okay, so we use the formula stated by LeBron, right? Yeah, LeBron, yours is a force over meter square. It's actually force over area. So we take the force of 8 newtons, then divide by our area, which is 0.0000012. Okay, I just put as 126. Okay, so I round up over here. Units are important. Even when you are doing the working, okay, your units which are missing can cause you to lose marks also. Right, so I know the answer is not 630,000. It's 638 something something, right? Yeah, but the closest, okay, the closest is definitely, yeah, Oh, you got 636363. Okay, I'll just copy this down. Point, probably repeating, you're right. Okay, so I can write this down, right? So the closest is actually this. So I think in between when they were doing the calculation, right, they round up, round down before they reach the final step. Okay, and again, I will say, in your exam, your teacher is not going to tekan you this way, such big numbers or such small numbers. Yeah, and then you don't have a definite answer kind of thing. You see how different this is, right? 636, and then this is 630. Right? So, but this is good, practice for all of you. Ken, you understand how to do this now? So there are a few steps for you to take note. Always change to SI unit first before you calculate your pressure. So area, before you can even calculate area, you think about, what can I change to SI unit first? Do that, then calculate your area. Then after that, with that, you can put in the values into the formula. So you have force over area, you should get your answer. And recall, okay, 1 Newton per meter square equal to 1 Pascal. Yep, so that's why when we convert, it's just a direct conversion. Okay, LeBron, be very careful. You can lose marks that way. Like just now, you almost did. Okay, so this is the way you do it. Let's go on. Question 2 should be pretty easy. So diagram below shows two objects, A and B. They are brought close to each other. Someone is in, hold on. Right, they are brought close to each other. Okay, so on the left, you can see, right, so when they are about 3 cm apart, object A pulls object B towards it until they both touch each other. Okay, so which of the following statements about the two objects is not correct? Okay, so A pull object B. Yep, since A can pull object B, A supposedly should be a magnet, right? A strong magnet. All right, so object A must be a permanent magnet. That is very possible. So B experiences the force of attraction from A. This is also okay. Sounds okay. All right, so next one, both objects have the same pole facing each other. So this is wrong. If they have the same pole facing each other, supposedly north and north, what will happen? Will they attract? They will repel. Yeah, so there should be repulsion instead of attraction. Okay, so object B must be made of iron or steel. Okay, this is true because it has got to be a magnetic material, so it can be attracted. Now, rather than just iron and steel, do you know what are the other metals that can be magnetic material? Cobalt? Nickel? Yeah. Do you know that our coins, right? Singapore coins is magnetic. Do you all know that? You all know are good. Yeah. The old coins are not. The new ones. Yeah, Harvard, that's right. The old ones are not. Okay, the new ones are. Because of, the components in it. Yes. Right, so let's go on to the next one. Now, back to pressure again. An object of surface area, okay, 20 m square is resting on the floor. Okay, it exerts a pressure of 200 Newton per meter square on the floor. So what is the force of the object acting on the floor? What is the force of the object? I think this is pretty straightforward. Okay, so the first thing you do, okay, LeBron, follow your formula again. Okay, but I change it to A, so force over area. Okay, so always make use of this formula. Okay, now, so you can see that it exerts a pressure. Okay, exerts a pressure. So we have this value. We have the area as well. Okay, so we are looking for force. So if you are familiar with the triangle